Thank you very much to being here. And I want to thank also to organizing committee and the Complutense University to allow me to present this talk. I want to present the last patent developed for our groups that is related to bioequivalence or the determination of the bioequivalence between generic and reference drugs using laser spectroscopy. We want to present some concepts to understand the importance of this patent. Bioequivalence is when a new drug is developed, this new medicine is protected by a patent. After 25 years, the patent expires, and any other company can develop a similar drug called generic. So only the right amount, the concentration of active compound is unknown. But other constituents or excipients, the concentration of excipient is unknown. So the companies need to demonstrate the bioequivalence of the generic drug respect to the reference drug. To do that, the companies need to develop a bioavailability analysis that require in vivo study to demonstrate the bioequivalence. In this case, the concentration of the active compound is measured in the plasma. In some specific case, when the active compound have high solubility or high permeability, it's possible to request an exception called Bioequivalence, and it's possible to develop an in vitro analysis. In this case, the measure consists in obtaining the dilution rate in function of the time. There are 4 types of active compounds according to the biopharmaceutical classification system based on the solubility and permeability characteristics. The compounds belong to class 2 and class 4. It's not possible to develop in vitro analysis. So, in any case, if the analysis is developed in vitro or carried out in vitro or in vivo, this represents a high cost for pharmaceutical industry. In our work, we use for drugs from very high concentration, like paracetamol, to lorazepam have only more or less 1% in concentration. And also, simvastatin belongs to group 2, the according of the biopharmaceutical classification system. In all cases, we use the reference and almost 2 generic drugs. So the experimental setup is a typical LIPS setup is laser-induced breakdown spectroscopy technique. That is an analytic technique to obtain information about the sample. In this case, the sample preparation is a little special because we use 20 pills to obtain the power and then filter with a 100 micrometer filter, and then using a press obtain again the pills. So this process is because all drugs contain a film over the surface. So we obtain homogeneous samples. This is the results, but it's not so important. But the main question is we use to analyze the data, use 2 different factors, factor F1 and F2. That this factor is used by United States Drug and Food Administration, and the European Medical Agency to define the bioequivalence between two drugs. So if the factor 1 is ranked from 0 to 15%, and similarity factor ranked from 50 to 100%. So in our case, all bioequivalence factor was correct, and we demonstrate that this method is able to obtain the bioequivalence between reference and generic drugs, including very low concentration or drugs such as this cirvastatin that belong to class 2. So this result obtained using LIPS, spectral information, are an important evidence that justify that all generic drugs are bioequivalent with respect to their corresponding reference drugs. So this is the first case of the LIPS technique that was successfully applied to bioequivalent drug analysis, and LIPS technique could be introduced as a new alternative to conducting bioequivalence studies. Thank you very much.